All right. Two-step inequality word problems. Write and solve an inequality for each problem. Number one, 3 times a number increased by 4 is no more than negative 62. Isaiah, 3a. All right, so 3 times a number. You could use a for our mystery number here. You could use any letter you want to, any variable you want to, but I like a here. 3a, and then it says it's increased by 4. Go ahead. Add 4 to that. And this can be the tricky part, because you did all that last chapter. It says is no more than negative 62. What inequality symbol should I use? Isaiah, I'll let you finish this one for no more than. Less than or equal to. That's right. So think when it says it can't be any more than negative 62, that makes negative 62 the maximum. And if it can't be more than negative 62, it's going to have to be less than or equal, which is exactly what we have. So now we solve. Now, so far, we've only been solving one-step inequalities, but you guys have solved two-step equations from last chapter, and so you know the drill. What number should I get rid of first, the 3 or the 4, Jade?
4.
The 4. Excellent. How do I get rid of that plus 4? Perfect. So subtract 4 on both sides. Jade, negative 62 and negative 4 join forces or go to war? Excellent. To make what? Negative 66. So the same step that you would do first to solve an equation, same thing we do for our inequalities. Luke, what do I do now? Divide by 3 on both sides. Now, Luke, when you divide by 3, do you have to flip the sign?
No.
I'm going to ask you guys that every single question. Now, when we did one-step inequalities, it was only the multiplying and dividing ones that I had to ask you that on, because of course you don't flip anytime you're adding or subtracting. But with these two-step inequalities, we're going to be multiplying and dividing every single time. There's always an add or subtract step that we just did, that Jade told us to subtract 4 from each side. And then there's the multiplying and dividing step. Luke is correct in saying that we don't have to flip this because we're dividing by 3. It doesn't matter if it's negative 66. It matters what you're dividing by. Luke, what is negative 66 divided by 3?
Negative 33.
Negative. Nope, you divided by 2. By the way, you can use calculators. Just thought I'd throw that out there. So if you want to get a calculator out, you might use it later. We'll go to you, Tyler. Negative 22. That's correct. That's our answer. And we don't have to graph this, so we can move on to number 2. Yes, Mara? You can borrow a calculator, sure. Yeah, if you guys need to borrow a calculator, they're over there in the bucket. The quotient and the quotient of a number and negative 5 increased by 1 is at least 7. Isaiah, you already gave the last one to us, so someone else want to try this one? Gavin? How do I write the quotient of a number and negative 5?
N divided by negative 5 plus 1.
Perfect. Stop right there. So the quotient means that we're dividing. He's written as a fraction because that's how we show division problems within equations or inequalities. We write it as a fraction. So he didn't write negative 5 divided by n. He wrote n divided by negative 5. N being his number. We used a last time. N this time is perfectly fine. And then it says increased by 1. So he wrote plus 1. Is at least 7. Gavin, what symbol should I use if it says at least 7?
Greater than or equal to?
Greater than or equal to is correct. When it says that it's at least 7, that makes 7 the minimum it can be. Unlike last time, which was a maximum. If 7's the minimum it can be, that means it's going to be greater than or equal to. Can't be any smaller because it's at least 7. So now we're going to solve 2 steps. 2 steps. Step number 1. Alyssa, should I get rid of the negative 5 or the 1 first? Yes. How do I do so? That's right. So we always get rid of the constant number first, unless, of course, it's a big fat fraction. You think you're going to see any of those this chapter? Just wait till Thursday's worksheet. Alyssa, what is 7 minus 1?
6.
Okay, so n over negative 5 is going to be greater than or equal to 6. Notice I'm not asking Alyssa if she has to flip the sign because that was an add or subtract step, and I never flip the sign when I'm adding or subtracting. However, the next step is a multiply divide step. Austin, what do I need to do to both sides to get rid of the negative 5?
Multiply by negative 5.
That's right. Multiply by negative 5. try to color coordinate this so you guys can see the steps in a different color. There we go. Austin, when you multiply by -5 on both sides, do you have to flip the sign?
Yes.
Yes, you do. That's right. So now we're gonna have n is less than or equal to. And then Austin, what's 6 times -5? -30. Yeah, so this is one that we have to flip on. That's because he told us to multiply by -5. These aren't bad, are they? I mean, this is tomorrow's lesson, a day early. This is, you guys have already done this, so it should be just a bunch of review. Tyler, you want to give the next one a shot? Okay. Number 3 says 6 less than the product of a number of -2 is fewer than -18. This one can be tricky, so I'm interested to see what you say here. Because this is the one where a lot of students are going to slip up. Go ahead. What do you think? Stop right there. He's absolutely right. -2 and y are being multiplied together because it says product. So we can write -2y. And then it says 6 less than that product. So we are subtracting 6 from that. It's not 6 minus 2y. It's -2y minus 6. 6 is being taken away from that product. So I write it just like that. And then Tyler, it says is fewer than. What symbol should I use if it says fewer than? Less than symbol. Yep, you're right. And then what? -18. Good job. All right. Cadence. Do I get rid of the -2 first or the -6 first? Good. How do I get rid of that -6? Good. Add 6 to both sides. It's going to make the -6 go away. It leaves us just with the -2y. And then Cadence, what's -18 plus 6? They join forces or go to war? They go to war. Who wins the war and by how much? Good job. Okay. Amara, how do I get rid of the -2 now? What's the -2 doing to the y? And it's written right next to it like that. What's that indicate? What's that show? The -2 is being what to the y? Help her out, Chloe. What's the -2 doing to the y right now? And it's written right next to it like that. Not adding. They'd put a plus sign if it was adding. Not subtracting. Not dividing. What's product mean? Multiplying. Yeah, that -2 is being multiplied to the y. So to undo that, what would undo multiplication? That's right. We're going to divide both sides by -2. Divide both sides by -2. Chloe, do I have to flip the sign if I divide by -2? You should know this.
Yeah.
We do. We have to flip the sign. Anytime we multiply or divide by a negative, we have to flip the sign. So y is now going to be greater than. What's -12 divided by -2, Gavin?
-6.
Just +6. Yep, 2 negatives will cancel out, make a +6. So this is one that we have to flip on, just like the last one that we did. Anytime you multiply or divide by a negative, you got to flip. Number 4. The quotient of a number in 3 minus 2 is at most -12. Who'd like to give this a shot? Austin. The quotient of a number in 3.
X. divided by 3.
X divided by 3. I like it. Okay.
Minus 2.
Minus 2. That one spells it out for you, doesn't it? Is at most negative 12. What sign should I use?
Less than or equal to.
Less than or equal to is correct. Nice job. If it says at most negative 12, that makes negative 12 the maximum. And if it can't be any bigger than negative 12, it's going to be less than or equal than that. Okay. All right, Olivia, should I get rid of the 3 or the negative 2 first?
Negative 2.
Great job. How do I do that? Okay. Negative 12 plus 2, Olivia, is what?
Negative 2.
Negative 10. Yep, they're going to go to war. Negative army wins by 10. Everything else gets copied down. Remember, this is how we show our work. Regardless of whether we can use calculators or not, you still have to show me what step you're doing to both sides. Now, there really hasn't been any problems that I've needed a calculator on, but occasionally there might be one where the numbers are too big and I need to do that off to the side. I don't have to show that side work now, but I still need to show what I'm doing to both sides. Now, to get rid of the 3, Draven, what do I have to do? Multiply by 3. Draven, when you multiply by 3, do you have to flip the sign? Nope, because 3 is positive. And Draven, what is negative 10 times 3? Negative 10 times 3. Nope. Negative 10. What's 10 times 3? Okay, what's negative 10 times 3?
You're confusing.
Miley?
Negative 30.
Negative 30. Yeah, the one negative makes the answer negative. I prefer not to know what's going on in Draven's mind, so I don't even know want to know where he came up with the 6, but
I need more, I mean.
10 minus
10 minus 3 is 7, not 6. Oh geesh. Oh geesh. We're okay. Let's move on before we really embarrass Draven. Now, 5, 6, 7, and 8 are problems where they're more of the story problem variety, where instead of just replacing words and symbols, I'm going to have to think more in depth about this. Tyler needs at least $205 for a new video game system. He already has saved $30. He earns $7 an hour at his job. Now that's below minimum wage, so I'm assuming that he's working for a neighbor getting paid to rake leaves, or I don't know what it is, right? Find the minimum number of hours he will need to work to be able to buy the game system. So how much money, if we work chronologically here, how much money does Tyler already have saved? How much? You can just shout it out. 30. Okay, so we'll start with 30. Okay. Then he's going to be saving some more, right? His job pays him $7 per hour. So if he's going to be saving more money, we can add $7 to that for every hour. And we don't know how many hours that is. In fact, the second sentence or third sentence says, find the minimum number of hours. So somewhere on this, let's go ahead and define our variable. Let's let H equal the number of hours. That way we know what we're trying to find here. So he's got $30 plus he's going to make 7 per hour. So 7H. The bigger H is, the more money he's got. Meaning the more he works, the more money he gets. That expression represents how much money he's going to be saving. We need that to be at least $205 in order to buy the video game system. So does that need to be greater than or equal to 205 or less than or equal to 205? Yeah, it's got to be greater than. He can't spend money he doesn't have. So that's got to be greater than or equal to 205. I know that it can be equal because if he has exactly 205, he can buy the video game system. We're assuming that tax is included here, hopefully. But obviously he could make more than that and still have some money left over. So now I need to solve for H. So Blaine, do I get rid of the 30 or the 7 first? How do I get rid of the 30? All right, so if you subtract 30, essentially what you're doing is you're taking away the $30 that he already has put away. So What's 205 minus 30, Blaine? This is where our calculators could come in handy. What'd you get, Blaine? Say it one more time. 175. Okay. So if he's already saved $30, he only needs to save 175 more dollars. Now he's making $7 per hour. How do I get rid of the 7? Kara? Yeah. See how many 7s go into 175? That's how many hours he's gonna have to work. Divide by 7, divide by 7. Kara, what's 175 divided by 7? 25. And what did H represent? Hours, not dollars, right? Hours. So he's going to have to work at least 25 hours. That'd be the minimum number of hours until he saves up for that video game. That's assuming he doesn't do anything else to make money and just other than just working that job. You quit your job, you won't be making any money, Hugo. So make sure if you are quitting your job, you have another one lined up. All right, number 6. Oh, by the way, make sure we label that. That's a story problem, correct? Okay, so make sure you labeled it. Number 6, Katie is starting a babysitting business. She spent $26 to make signs to advertise. She charges an initial fee of $5 and then $3 for each hour. This is pretty cheap. This is not realistic. I don't know about you girls, but if you were babysitting, $5 and then $3 every hour.
I quit.
Find the minimum number of hours. Again, there's H again. Find the minimum number of hours she'll have to work or babysit to make a profit. Now remember, she's already spent $26 advertising, so she's $26 in the hole. So if you want to make a profit, you're going to have to make at least that $26 back, plus anything extra is then the profit. So she has spent $26, but she spent that money. So Caitlin, it's negative 26. Okay. But she's making money, so we can add to that. She's going to make what? Actually, I apologize. Don't start with the 26. We need to start chronologically about this. It didn't ask us how much money she'll be making. It wants to know how many hours she'll work until she gets out of that hole, right? Until she starts making a profit. So that 26 will come in just a moment. Let's start with what she's making. She charges her clients, if you will, how much? What? $3 to $5. She charges them $5.
Yeah, it says fee.
Okay. What else?
$3 for each.
$3 for each hour. So just like before, H equals the number of hours. In this instance, that she babysits. So 5 plus 3H represents all the money she's got coming in. To make a profit, she's going to have to do what? Earn back the $26 that she spent, right? If she makes exactly $26, has she made a profit? No, she's just broke even, actually, right? So in order to make a profit, she's going to have to make more than or greater than $26. All right. So if you take away the $5 fee, what's 26 minus 5? 21. How do we get rid of the 3? You go. How do we get rid of the 3? Caitlin? Caitlin, when you divide by 3, do you have to flip the sign? Nope, because it's positive. Caitlin, what's 21 divided by 3? 7. So she'll have to babysit for at least 7 hours. Sorry, I shouldn't say at least 7 hours. For more than 7 hours. Because if she babysits for exactly 7 hours, she's broke even. So it's the 8th hour, or just over the 7th hour, that actually she turns a profit. I don't know. I kind of like the $7 an hour job that we had in the previous problem. Because this is only $3 an hour. Yes. I can't hear you. Sure. Number 7, as a salesperson, Audrey earns $75 per week plus $5 per sale. This week, she wants her pay to be at least $125. Find the minimum number of sales that Audrey needs to make. Laura, you gonna try this one? Okay. What are we trying to find? The what? No, we're not trying to find her minimum wage.
I know you're really working hard and I do appreciate it, but what kind of cells can I give these kids kind of practice what we've been doing?
Any of the 7th grade TI cells.
Like that one? This is the one Johnson.
That's 2-step inequalities. Yeah,
Are we not even done
that's
this yet?
that's tomorrow's lesson. If they then maybe do T1 through 4, they should be able to do. You need me for a second? Okay.
Fine, is that gonna interrupt? Okay.
Okay. This is one where a calculator might actually come in handy, although some of the other ones we haven't needed it so far. So what are we trying to find? Olivia, what's this problem asking us to find here? All right, how about S for sales? S equals the number of sales that she has to make. So she gets paid $5 for every sale, but there's actually something else included in her salary. She also gets paid what? Cadence? Yeah, she gets paid $75 each week. So if she wants this week to earn at least $125, she knows she's already making 75 plus $5 for each additional sale. If she doesn't sell anything, she's only going to make $75. Probably not going to have her job for much longer as well. But she makes $5 for each sale. She wants to make at least $125. So do we want that expression that represents how much money she's making? Do we want that to be greater than or equal to 125, or does she want that to be less than or equal to 125? Isabel? That's right. Greater than or equal to 125. Because if she says at least 125, that means she's okay making more. Right? She's okay making more. Austin, your iPad needs to be down. Okay, we're on the paper. Okay. Same with yours, Justin. Mason, did I give you a paper? Mason, we're working on number 7 out of 8, but I've been recording these problems, so I'm going to post that video and then you can turn it in after you watch it and get all 8 points for this worksheet. All right, so let's see. Chase, I haven't called on you yet. Chase, do we get rid of the 75 or the 5 first? Oh, the 5 is with the variable. Hang on to that. Get rid of your constant first, which is 75. Yeah, get rid of the constant number first. Okay, Luke, stop with the calculator case. Chase, what's 125 minus 75? 50. Okay. That means that if you take away the $75 she's already going to make no matter what, she needs to sell $50 worth of things. Well, she makes $5 per sale. Then Jade, if you divide both sides by 5, that means she would sell how many things? How many sales would she have? 10, exactly. Oh, do we need to flip the inequality symbol, Jade, when we divide by 5? No, because it's not negative. So 10 sales. We don't know what it is she's selling, but if she sells 10 of them, she'll make that $50 so that you add it with the 75 and she'll make at least $125 this week. And number 8. Elijah and his sister went to the movies. They had $34 altogether. and spent $9.50 per ticket. Now, how many tickets, this is implied, how many tickets did they purchase? We're assuming 2, if it's just both of them, right? Elijah and his sister bought some snacks. Find the maximum amount each person spent on snacks. Because you know they only have a total of $34. So the first thing they did when they got there was what? Get the tickets. And how much money did they spend on tickets, assuming they bought 2 of them? Kara? Not $34. That's how much money they had. But how much of that money did they spend on tickets? Per ticket. They bought 2 of them. Gavin? $19. That's what 9.5 times 2 is. So they spent $19 on tickets. We get that? Okay, $19 on tickets. Plus, they're going to purchase some snacks. Now, we don't know how much the snacks are going to cost, but it says that they're going to purchase the same exact snacks. So meaning whatever person A spends, person B, Elijah and his sister, going to spend the same amount, right? So take what one person spent and you can double it. Now, we don't know how much money they're spending on snacks. Maybe we can let S represent snack money. Or money for snacks. So $19 for the tickets, plus S represents the money for snacks, but it's not just Elijah, it's his sister he's got to pay for too. So whatever he buys, he's got to double that and buy it for his sister. So $19 plus twice the amount of snacks, because there's 2 of them. Does that amount have to be less than 34 or greater than 34? What do you think, Marley? It's got to be less than 34. Can it be equal to 34? Yes, because they could spend exactly $34, which is all their money, and that would be okay. But they can't spend more than what they have. So now I go ahead and solve this. Hugo, should I get rid of the 19 or the 2 first?
The 19.
All right, how do I do that?
Subtract it out of 34. You get 15.
Okay. Now, Aiden, how do I get rid of the 2?
Divided by 2.
Divide by 2. Aiden, when you divide by 2, do you have to flip the sign? Nope. So really none of the problems on the back side, we've had to flip the sign. Had to on the front side a couple times. And Aiden, what is 15 divided by 2?
7.5.
7.5. Now, can you buy a half a snack?
Yeah.
Probably not, but does S represent snacks? It represents the money for the snacks. Can you have half $1?
Yeah.
Sure. In fact, how would I label this? Not 7.5, but $7.50. There we go.
$7.50.
You can spend $7.50 on snacks. Yeah. All right, this is done. Would you make sure your name's on it and pass it forward? If you're done with it.